too.
Okay, we can do that.
Yeah.
Just to make sure that
Yeah, we can test it then.
it's
that
working.
good?
Yeah, totally. And this one is.
Okay, we'll
Yeah.
play around with it later.
Yeah. Well, I need to get it to work to begin with. So.
Right. All right. Thanks, Joey.
Of course. And there is a clicker up there for you.
Test, 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 testing, 1, 2. Up to volume level. Hit it again. Test, test. I might need to turn the volume up because it's down here, with her, but.
All right, good morning, everybody. Thank you all for coming to our fourth aquaculture workshop. We are going to get started slowly here. It sounds like there's still a few people coming in at the gate. So if you see some people trickling in, don't get distracted. Thank you so much for coming. Who has been here with us before? Oh, wonderful. Great. Thank you guys so much for coming back, and welcome if you haven't been here before. FAU Harbor Branch was founded in 1971, and we are now the northernmost campus of Florida Atlantic University, and we've been celebrating 50 years of ocean science for a better world. My name is Laura. I am the Outreach Project Coordinator. I love to share science. That's a big part of my job, and I'm excited to share aquaculture with you today. So aquaculture is the farming of aquatic plants or animals for food, research, or restoration. And at FAU Harbor Branch, we've been spending decades of developing techniques and technologies and have hosted workshops to educate industry professionals. Last year, Dr. Gabby Barbright McHenry, Director of Outreach and Engagement, partnered with faculty members here on a grant to host public workshops. The goal was to educate the community and people in the seafood industry. We wanted to talk about the important role of aquaculture and address some of the most commonly asked questions that we get. We are standing here now because we were awarded that grant through the Aquaculture Specialty License Plate that is administered by the Harbor Branch Oceanographic Institute Foundation. So thank you very much to the foundation. Please buy a specialty license plate. They're displayed here on the banner, and then also will come up here on the slide. All of the proceeds come back to support research. This is the last of a 4-part series, each one focused on a different topic. Last month's focused on shrimp, clams, and oysters, and the workshop was wonderful. So the presentations covered past, present, and future invertebrate research at FAU Harbor Branch, and also showcased local farms on the West Coast and in Sebastian, as well as an informative video from Sierra Films. If you missed it, it's no problem. It was recorded, and you can watch it online on our website. Today, we have an excellent lineup. We have scientists, industry partners, restoration partners, and more who are going to talk with us. Today's workshop is all about restoration and aquarium aquaculture. This is aquaculture's lesser-known application, and my favorite, growing marine species to restore impacted populations. Everything from fish to conch to corals, we're going to talk about it today. So before we get started, I do want to take a moment to honor someone who devoted much of his career to seagrass restoration in the Indian River Lagoon. With great sadness, we share the news of the passing of Dr. Dennis Hanasak, a beloved and renowned member of the FAU Harbor Branch research family. Dr. Hanasak was a research professor, director of Marine Ecosystem Health Program, the director of education at FAU Harbor Branch, and principal investigator on many research projects. He is remembered as an eminent marine scientist, a devoted teacher and mentor, and a conservationist. He was a seagrass restoration pioneer and was one of the first to grow seagrasses in aquaculture and transplant them into the lagoon with great success. Dr. Hanasak is a true icon of FAU Harbor Branch Oceanographic Institute. His passion was infectious, and his work made an unfading impact on the world. So, with that, a little bit of housekeeping. I'll be the MC. I'm going to introduce each presentation and keep us on time, hopefully. There are schedules or copies of the schedule on the stage here and here, so feel free to grab one if you did not this morning. We will have 6 speakers and then a panel discussion at the end, just like the previous workshops. If you think about a question, please take a mental note, write it down, and save it for the Q&A panel at the end so that everybody can hear. We encourage you to take notes, photos, etc., but do remember that this session will be recorded and you can watch it again online if you'd like. So with that, please silence your cell phones and let's get started. Our first presentation is going to be given by Dr. Jim Masterson. He's a faculty member and assistant research professor at FAU Harbor Branch. He has a diverse background in marine science, especially in aquaculture. And this presentation will introduce how aquaculture is used for restoration and the aquarium trade, focusing on freshwater ornamental species, which have an interesting history. He will also touch quickly on Dr. Hanasack's seagrass restoration work. So with that, please welcome Dr. Masterson to the stage.
Thank you very much. Yeah, I might crack a little bit up here as well. So we're going to talk about all of the non-food aquaculture today. And so far we have been talking about aquaculture for food purposes, feeding a hungry planet, alleviating fishing pressure. This is U.S. production from 2018, and you can see the food uses of aquaculture being the most prevalent. But down on the bottom, we've got ornamentals and sport fish and bait fish. So those are good examples of non-food aquaculture. The role aquaculture plays there, including stock enhancement and restoration aquaculture. So pond stockers and the more ecosystem service-based restorations that you're going to hear about for most of the day. But bait fish aquaculture, where is that coming from? Can somebody turn off all the mics but the front one?
They are.
They are. So bait production, fee fishing, ornamental aquaculture that you'll hear about from myself and Jordan today. There's biomedical applications. There are organisms like sponges and this tunicate here that have anti-cancer compounds within them. And perhaps we're not quite able to synthesize analogs. We might not be able to harvest enough while protecting those resources. So maybe aquaculture can be used in an interim capacity to grow those organisms for research purposes. Non-food algal culture. Scientific research is another use for aquaculture aside from food production. These little zebrafish here, just amazing organisms, and they're second only to rats and mice as far as animal research. They have 84% of the genes known to cause diseases in humans in their genome. So they're a wonderful model to be used in that kind of research. And the move is to use the least sentient organisms in research, organisms least likely to feel pain as we perceive it. So there's a move away from the primates and the rodents and onto other vertebrate models. So that's a really important aspect as well. I'm going to talk mostly about ornamental aquaculture, and I'm going to stay on the finfish, on the freshwater side of things, and Jordan's going to talk about marine ornamentals. First, I want to just kind of point out where this might make economic sense to grow pets instead of growing food. We talked about hybrid striped bass a couple of months ago, and they're fetching $3.50 to $5 a pound right now, farm gate. So you can make a living growing hybrid striped bass. Something like a Cory catfish, you might only get $1 a fish these days. Sometimes less, sometimes more. But these are teeny tiny fish. And so our systems don't care what you're growing. It's related to biomass. And I can grow 30 Cory cats and produce the same amount of weight as that 1 pound of hybrid striped bass. So that's $30 a pound farm gate that I'm getting for something like that. So it might make economic sense to pursue an ornamental avenue as an aquaculturist. As with so much aquaculture, as we've learned all spring, most of this is focused outside of the United States. Most of our ornamental production is in developing countries, in tropical and subtropical environments, and this is an employment opportunity for thousands of rural workers in those developing nations. Singapore is the single largest global producer, and you can see their chunk of the pie there, and they contribute almost 20% of the total supply of global ornamentals. They're also the trading hub in Asia for ornamentals, and actually 30% of what gets exported from Singapore is coming from elsewhere, landing in Singapore, and then being exported from there. Asian countries, they account for about $200 million in export production. That's 2014 numbers, and we're a little off that number right now. So that's almost 60% of the global export total. We are the largest importer of ornamentals. We also do show up on the pie for high-value species that we produce and we export elsewhere. And our production totals about 4% of that global total. There's over 2,500 ornamental species or varieties of fish globally that are in the trade, but the market's only dominated by a few dozen freshwater fish types. So things you're probably familiar with, especially if you grew up keeping aquariums at home. Our live bearers, our guppies and platies and mollies, neon tetras and freshwater angelfish and goldfish and danios and discus, the bread and butter staple crops make up most of the trade. Just these two groups, guppies and neon tetras, it's 25% of the global market and 14% by value, just in those two species groups. Bringing it back to the United States, you'll recall if you were here the first week of the series, we noted that Florida, we come in at number 9 as far as overall aquaculture production in the states. But we do have the highest diversity of species grown anywhere. We have a warm subtropical climate, so we have high rates of production year-round or nearly year-round growing seasons. And what puts us at number 9 is this very large ornamental trade. And that's at the top of our production here in Florida. You'll see some different numbers. This figure from FDAX puts ornamentals at just over half of the Florida production totals. I've seen anywhere from 37% to 51% in publications in recent years. It's the largest single sector in Florida aquaculture in any case. You'll also see that we have got aquatic plants in here. Most of those are ornamental, although some food plants do show up in there as well. And then that other component includes the restoration aquaculture that you're going to be hearing about. So we're the biggest ornamental producers in the nation. Most of the industry is focused on freshwater ornamentals, growing marine industry that you're going to hear about, and we produce hundreds of species and varieties in the state. Why are we the aquaculture capital of the U.S.? Location. We've got a warm climate, so we can grow tropical and subtropical species. We also have proximity to ports and to airports and all of the shipping corridors for national and international commerce. We also do live in an aquaculture-friendly state. We're a single agency state where FDAX oversees all of the regulations, and for the most part, it's a pro-aquaculture climate. So said we're number 1. It's to the tune of 95% of all of the ornamentals produced in the United States are coming from Florida. There's about 200 nominal producers. It varies to maybe 100 and 150 producers that actually report production in any given year, but they collectively raise several hundred different varieties of fishes. Our industry is concentrated in these two counties on the West Coast, Hillsborough and Polk counties, and also a concentration down in Miami-Dade, but we've got farms throughout the southern half of the state. This gentleman here, that's Craig Watson. He's the director of the Tropical Aquaculture Lab over in Ruskin, and they are celebrating their 28th anniversary this year, and they have done a lot. IFAS has done a lot to promote this industry. Our 2018 sales totaled just under $30 million. There were only 109 operations reporting. Aquaculture usually underreports. Only about 40% of the farms respond with their production numbers. But this still puts us first in the nation for koi, for saltwater ornamentals, and for freshwater ornamentals. And we see that it is, Florida produces more than twice the koi as Missouri, the next biggest producer, but it's a couple of orders of magnitude more when you get down to the freshwater ornamental fish. That sounds like a pretty good number, that $28.7 million, but that represents a dip over the last 20 years. We were up at about twice that in 1997. There's been some ups and downs, but mostly this has been a downward trend in overall production. The industry basically attributes this to there being an overall decline in the aquarium hobby in the United States over the last 2 decades. We still are the largest importer of hobbyist species, but there's not as many of us at home that are aquarium keepers. I suspect that's because most of the kids, their aquarium keeping is happening on their smartphones. It was the case in my kids, sadly. So in a lot of Florida, using small earthen ponds, this is still the most common ornamental culture system. As we have seen elsewhere in aquaculture, there is a trend toward intensification with culture techniques becoming more refined, allowing higher stocking densities, using RAS technology to maximize production, to reduce losses, and to be a little less water consumptive. But this is still a widely used traditional production methodology. This can get you into trouble when we have periodic hard freezes in Florida. And 2010 and 2011, those were the last big cold snaps we had in Florida. 2010, we had 2 periods where we had 10 plus days of sub-freezing temperatures in a lot of the peninsula, and the freshwater ornamental industry really took it on the chin those years. Here you see people scrambling to put the visqueen over their small ponds. It's not cost effective to be able to heat those ponds. Here, this is a Lakeland farmer scrambling to get those high-value angelfish out of the ponds and into a greenhouse, and hopefully able to save them. So this 2010 event, it cost the Florida ornamentalists about 70% of their production. The average farm is only making around $260,000 gross. These are mom and pop operations. So to lose 70% of that is quite a bit. That's like $180,000. Even the farms that carried insurance, the standard insurance policies would only reimburse up to about $100,000 in losses. And it'd take 7 or 8 months to get there. So we had attrition after this event, and did so in 2011 as well. So this is a concern, maybe less of a concern as our mercury is rising year after year. Though it's a concern, it's down here on the list of concerns as far as the farmers ranking them. They actually cite regulatory hurdles as being of greater concern. We are an aquaculture-friendly state, but there's still costs associated with regulatory compliance. And IFAS study, it was data that was collected in 2018 and published in 2022, suggests that the regulatory costs across the industry in 2018 were $5.2 million. So that's an average of $173,000 per farm. But the value lost due to regulations, $23+ million. That's nearly the total aquaculture production, ornamental production in Florida. So, there seems to be a suggestion that they should be making about twice as much. Regulations certainly are important, but should the non-food aquaculturists have to be restricted to the same set of chemotherapeutants that the food producers are restricted to? Those are the kinds of questions. Maybe they should be allowed to use, other drugs. There's still restrictions on, what kind of anti-predator steps they can take, water restrictions, etc. And economy of scale doesn't work for those mom and pop farms. The cost associated with overcoming regulatory hurdles is greater for those small producers. So just like with the larger global industry, there's only a handful of groups that make up most of what's produced in Florida. There's 8 groups basically that are the bread and butter crops, including the cyprinids, all the minnows and the carps. The zebrafish are in this group. The tetras, pacus, piranha that are illegal here in Florida all fall in this group. The characiforms and the cory catfish and the suckermouth catfish are plecos there. Rainbow fish, all of those live bearers, the pusiliids, guppies, and platies and mollies. Cichlids, hugely popular, and this is where those beautiful discus fall in. Gouramis, that makes up the bulk of what is produced and sold in Florida. So finishing off my ornamental talk, I will touch on some smaller components. There is a freshwater and marine invertebrate and a live rock component to our ornamental story in Florida. There were only 17 operations that reported in 2018. That data was withheld because if you have that few number of producers, people can figure out who's producing what. So there's a little bit of secrecy there. But sales from 12 operations in 2012 totaled a little over $370,000. We're going to hear about the marine ornamental side of things momentarily. Aquatic plants is part of the picture as well, and this includes those plants grown for water gardens and aquariums. Some of the food market aquatic plants get reported here as well, including watercress. Plants for wetland restoration are in this figure as well. Dr. Davis is going to talk to us about conch today, but she could be talking about the sea veggie production here as well. And that would be in this category of aquatic plant production. So most of our live aquarium plants that we can purchase in the United States, they're grown here in Florida as well. Like the fish story, we had a peak about 20 years ago, $21 million of aquatic plant sales, but they've been in decline ever since. And it's the same story. There's a declining number of hobbyists that are buying that product. 2005, it was $17.6 million. And in 2012, it was down to $5.3 million. So we see the same trends there. I'm going to transition and talk a bit about Dennis's land-based seagrass nursery. So this is a restoration example of aquaculture, not per se for sport enhancement, although we know that seagrasses are an important nursery ecosystem, but this is an ecosystem services restoration. The important roles of seagrasses, if you've been to our ocean science lectures, these are familiar to you. These are highly productive systems providing substrate and habitat, the nursery habitats for the estuary, food for local consumption, detrital production for export to adjacent systems, lots of important nutrient cycling, sediment stabilization, etc. And an acre of healthy seagrass can provide shelter for 40,000 fish and for 50 million invertebrates. So there's an important role there. Economically, we've got a IRL fishery value of more than $1 billion when you combine commercial and recreational fisheries. Again, if you've been to our lecture series, if you attend our lagoon symposium, you know the seagrass story here in the lagoon. A big loss, 60% loss between 2009 and 2012. Those losses preceded, the beginning of the losses preceded the 2011-2012 super bloom. But certainly that exacerbated the situation, and we see similar losses throughout a lot of the world. Typical seagrass restoration, traditional seagrass restoration has occurred through transplanting. And typically you will take material from a healthy donor bed. You thin that bed and you try to replant lost seagrasses. These pictures are from a 2015 restoration feasibility study. There's Dennis right there. He's working with Bob Vernstein from St. John's River Water Management District, since retired. But looking at the feasibility of doing this kind of transplant work and trying to answer the question if it is a adverse environment or if it's potentially a lack of propagules, a lack of vegetative fragments that slows down the recovery of these beds. And in 4 of the 5 beds that they planted, the environment seemed to be conducive to the seagrass surviving. So the notion here is that let's not rob Peter to pay Paul. Can we figure out how to not compromise the health of those donor beds, but still be able to try to transplant and recover those seagrasses? So that's where the land-based nurseries come into play. So again, in 2015, Dennis established our land-based seagrass nursery here. The goal is to provide a source of donor material for transplantation to the lagoon that isn't compromising the health of existing beds. The initial technical capabilities and infrastructure came through the proceeds of that year's Love Your Lagoon benefit. And in 2022, Dennis got a grant through the Next Era Energy Foundation, and that is funding our current nursery operations. There's 3 or 4 years of nursery funding there. And the Fish and Wildlife Conservation Commission has agreed to fund the expansion of this nursery. Currently, the nursery grows enough quantities of several different species to support pending restoration pilot studies. A big issue, a big challenge is to find areas of the lagoon that are going to be conducive to transplantation, where the water quality is such that those transplants have a chance of surviving. So the land-based side of things is an important part of the puzzle, but the long-term goal includes having to address those water quality, water clarity issues. So the heavy lift is reducing those freshwater inputs, reducing the input of the nutrients and the solids into the estuary, getting rid of those legacy nutrients in the system as well. So that's the harder part of the puzzle. We're not the only ones working towards these goals. Internationally, you see land-based nurseries. There's a big push in England and in Germany as well for land-based nurseries. Florida Oceanographic Society down the road, they've had a land-based nursery for several years. But just July of last year, the Seagrass Restoration Technology Development Initiative was passed both by the Florida House and Senate. It was signed by the governor, and so that shows that this is a priority in the state. And there's a combination of private and state and federal funding supporting the establishment and the expansion of existing land-based nurseries. Moat is bringing a big nursery online through NOAA funding, and they are going to be concentrating on the genetics of the seagrasses and trying to see what role genetics plays in the survival of this transplant material. I do thank you all for attending today's workshop and the other workshops if you've had a chance to get here. And I'm going to hand off to Laura, who just stood up and almost had the fishnet out to take me off. And I hope you enjoy the rest of the morning.
All right, thank you so much, Jim. Our next presentation is going to be given by Jordan No. He is the Director of Sales for ORA, which stands for Oceans, Reefs, and Aquariums. When consumers choose aquacultured ornamental species, try saying that 3 times fast, they help to take pressure off of wild populations, which often live on ecologically important coral reefs. ORA is doing a great job of making cultured products extra enticing, and I'm sure Jordan is going to share more on that. So with that, please give a warm welcome to Jordan No.
Hello, everyone. All right. Well, my name is Jordan No. As she mentioned, I'm the Director of Sales for Oceans, Reefs, and Aquariums. You may also know us as ORA. We operate what is likely the largest land-based marine ornamental aquaculture facility in the world, just over there on the back end of Harbor Branch, actually. We've got some skilled technicians that work in 7 departments on 8 acres to commercially raise fish and corals 365 days out of the year. And yes, that includes coming in on Christmas to make sure fish are fed. For over 28 years, we've been the leaders in marine ornamental aquaculture, helping kind of push the envelope forward on raising now well over 13 million fish to be sold not only domestically, but worldwide in over 30 international countries. But that's really only half of what we do. So in addition to the 50 species of marine fish that we raise, including all the countless variations of clownfish, we also operate a coral greenhouse where we raise over 150 distinct species of coral. And as a third major prospect of our company, we also operate a remote clam farm on the Majuro Atoll in the Marshall Islands. So just a quick brief history of me. I've been keeping aquariums and in the aquarium industry for over 24 years. I've never not had an aquarium. I love it. Clownfish got me really into working with marine ornamentals. And even growing up, I knew what ORA was. ORA was a company that was very familiar with anybody who had an aquarium in the early 2000s. And so coming here, it was really quickly apparent that there was a passion for preservation. And there was a really clear vision that was laid out in 1996 that detailed a goal to create or allow hobbyists to have a 100% completely aquacultured marine aquarium. Everything from the fish, the inverts, and the live rock. So just kind of a quick recap on where that comes from. Oh, sorry, these were supposed to come earlier. We'll talk about these real quick, actually. So, clams from our clam farm. Absolutely stunning varieties, all different species, different colors. These are our broodstock tanks where we keep all kind of the mom and dad clownfish or groups or harems of other fish species that we're raising. Our hatcheries. And all this originated back around 1973 with the Aqualife Research Center in Walker's Key. This was kind of a pioneer icon from Martin Moe, generating kind of one of the first commercial aspects of marine aquaculture. When this closed down in mid-90s, a little offshoot of Harbor Branch took in a lot of this equipment, the aquariums, the broodstock, and turned it into Oceans, Reefs, and Aquariums. So right around that time, raising clownfish in commercial numbers was really a pretty novel endeavor. But it wasn't until 2003 that it really took off. 2003, as you might remember, the movie Finding Nemo came out, and everyone wanted a clownfish, everyone wanted an anemone, and it really, really was a boost for marine aquaculture regarding clownfish. Here's one of the first tanks over at Harbor Branch, actually. As you can kind of see, our logo over the years advancing as we did. So 2003, Finding Nemo came out. Marine aquariums really started to get very popular. Here's us building some of our hatcheries, kind of expanding our entire infrastructure to kind of compensate for this little guy right here, the orange Ocellaris. Everybody knows this fish. This is the one that everyone wanted. And it's a darker variation that comes from Darwin, Australia. But it wasn't until this guy showed up in 2004 that things really, really started to change for the ornamental industry. So up until then, you may be surprised to know that designer clownfish weren't really even popular. They weren't even really desired. They were seen as kind of this aberration of what a traditional three-striped clownfish looked like. But from the genetics of this wild-caught percula clownfish, all sorts of new things could come out of your clownfish. This was a huge shift in consumer taste between these wild-type clownfish and the wildly interesting patterns that you could acquire with the genetics of the first designer. So the next year, in 2005, the first, this is actually what the fish was supposed to look like, the true percula. You get your three stripes, very simple, to this. This fish came into the market in 2005. This is a snowflake Ocellaris. And again, you've got this traditional three-striped fish, but now you've got an aberrant lines creating this kind of, some would argue a snowflake-like pattern. And from there, you can breed these traits to any number of different things. A stripeless clownfish, and it doesn't have to stick with the Ocellaris or percula complex. We've made spots on a traditionally two-stripe Bisinctus fish, gave it a nice little pearlescent blush over the eye. You can take a three-striped fish, turn it completely gold. These are all the wonderful things that just that single true percula that was caught in 2004 kind of allowed us to unveil. So back in 2010, that was another kind of big deal. This is the Mandarin Dragonette. Ouray was one of the first to kind of release a significant number of a captive bred version of these little fish, which is a pretty incredible achievement considering they're very fickle when it comes to what foods they eat. And they had a pretty high mortality when captured from the wild and put into aquariums. One of my favorites. They look like a little underwater butterfly. But what Ouray was able to achieve is raising a fish that came from South Florida rather than the South Pacific. It was eating prepared foods like pellets and frozen foods, and it really gave Aquarius a much better leg up on keeping the species long-term in aquariums in a way that wasn't really possible before. However, this fish did pose some significant challenges to us, which I'll touch on a little bit later. Very, very beautiful little fish. So this is actually a photo taken in June of 1985 from the aquarium of Dietrich Stuber. From the notes on what I've got from this, it's one of the first known documented cases of an SPS, or small polyp stony coral, growing and thriving in captivity. So just to kind of give you a quick rundown of what the industry or the aquarium hobby looked like in 1985 through the 90s, aquarium corals were being imported in from the wild. Nobody really knew how to take care of them. The best they could hope for is that it just wouldn't die immediately. But here was an example of a coral actually growing over the rock that was put into an aquarium. It was thriving by all accounts. Now, some 40 years later, we are actively raising this coral from material from that actual frag that Stuber had. This is the Ouray Stuber stag right there. It's been in captivity now 40 years removed from the ocean. That's how long we've been able to keep wild corals there. This one actually in active production. So this actually leads me to our coral greenhouse, one of my most favorite buildings to go to. every time you open the doors, it's like being immediately transported to the South Pacific, a coral reef at 30 feet by 150 feet and 20,000 gallons. This could be, and I believe is, the largest land-based commercial coral farm in the world. This is actually the second iteration of that. By 2007, we had finished this building, and we raise, like I said, 150 different varieties. We do something a little bit different than a traditional aquaculture facility working with corals, which may take a little piece, grow it into a very large colony, and then take small little fragments of that while maintaining a mother colony. Our strategy is taking fragments, growing those fragments out slightly larger, and taking fragments of that fragments and doing that kind of ad nauseum until you get multiple little pieces. And what's so great about these is you take a little piece off, you mount it to a little, in our case, a plug with some glue. It will grow into new pieces, which then can further and replicate more and more corals. So as you can expect, being in Florida, sunlight is how we grow our corals. We've got plenty of access to it. It also comes with the cost of highly added temperatures, whereas if you know anything about kind of the current state of the ocean, rising water temperature is what we want to avoid. So we've actually got 2 5-ton heat pumps per system in our building. One can handle it by itself, but 2 is redundant. We can suck out something around 90,000 cubic feet of air a minute using our 3 exhaust fans, all to keep our water temperature a nice, stable 78 degrees. This is one of my favorite aquariums. This is by Steve Wiest in the early 2000s, just kind of showing how far and how realistic you can make a reef experience in your own home. So a lot of the corals that we grow take about 2 to 5 years to get into a commercial number. We may start with a small little frag. Again, we make frags of frags. And it takes that long just to get to a stable number where we can supply a domestic and international market. So everything from our green planet, blue voodoo, and a red planet. So by the time we came out with the Mandarin Dragonet in 2010, we'd really already cemented our identity with producing these iconic corals. As I mentioned prior to this, people just had Acroporus hyacinthus, Acropora valida. That was kind of the nature of the hobby at the time. ORA came out with some catchy names, like I said, Red Planet, Blue Voodoo, and it really changed how people purchased corals. We collected a lot of these pieces, not from wild pieces that we imported, but actually other aquariums. In Germany, they were about 10, 20 years ahead of us in growing these corals. They were doing such a great job. They'd kind of already filtered out a lot of the more sensitive species, and so the ones they were growing in their aquariums were very tough. So when we took those back to Florida and grew these out, it really gave American aquarists a much higher leg up in keeping these corals alive at a time when it was really a very fledgling, sensitive hobby. This kind of jumps to 2012. One of my little favorite anecdotes is Ora was actually able to, and one of the first, to create an entire aquacultured genus. So this is the 3 assessor species. We've got the blue, the Randalls, and the yellows. Albeit it's a very small genus, only 3 species, but we actually conquered all 3 of them, producing a captive bred variety of these. One of my favorite things about these is hobbyists will oftentimes accuse us of producing a broken fish because of how it swims, like upside down on its side. But what's fun about this species is where it grows in the kind of northern Australia areas, it swims upside down in caves and overhangs. And so that's just a natural part of its behavior, which makes a really, really cool, fascinating fish in the home aquarium. So Ora is not without its challenges. We are obviously in Florida, and we endure kind of an annual summer onslaught of potential hurricanes. We've been very lucky for a long time, but in 2004 we had 2 hurricanes back to back within 3 weeks of each other that happened, just south of here, Jean and Francis. We had our roofs blown off. We had rainwater flooding our systems. It was enough damage that it actually impacted our fish production for about 2 years. So while we've got powerful generators to maintain our electrical needs, during extended periods of power loss. We've got detailed plans for storms and how to mitigate our damage. Obviously, being this close to the ocean and in Florida, we're kind of at the mercy of storms. So one of the other challenges that was touched on are legal challenges. So last year, we saw proposed amendments to the Lacey Act. And so while this was intended to regulate the movement of wild animals into and out of the United States, this amendment, S-1614, would amend the act with additional provisions that would effectively ban importation of non-native species into Florida. So creating basically a white list of authorized species, then just a black list of injurious species. How that's really bad for us is that the legal paperwork that would go into kind of banning everything and then adding individual species that were allowed into Florida would take years and effectively end all types of fish movement in the state and out of the state, putting thousands of farmers, millions of dollars of economic growth out of business. Fortunately, a lot of the state's largest fishers got together, we coordinated, and that bill is now just is currently just under review, which is a big relief because it was a very scary one. Other bills affect us that happen remotely. So in 2021, Hawaii banned all exports out of their fish, effectively again ending hundreds of jobs. But what this means for us in aquaculture is whenever those bans go into effect, those fish, we cannot now make them commercially available as an aquacultured alternative. One of the biggest things that we felt was in 2018, Bali banned all exports of their corals. Now, Bali was a unique experience in that there was hundreds, if not thousands, of commercial aquaculture farms operating in the ocean, operating and growing corals with that little impact to wild populations. And so banning basically both aquacultured and wild export really had a very big impact even domestically in the United States. One of the newer bills we have to face is the NEMO Act. It's a broadly written bill that reads very much like a full-scale ban on the full import and export of all aquatic marine life. And this is constant. It's every year. There's a new type of bill, a new type of ban somewhere. And it's easy to get fatigued about all these potential bans we face every year, but the only way aquaculture can continue is with the support of aquarists and the public alike. And the reason I say that is because it's critical to note that marine aquaculture cannot exist without wild-caught fish. So when a fishery closes down or a species is made unavailable for collection, it prevents any work with captive breeding. Some clownfish, well, all clownfish will spawn for you every 2 weeks for up to 50 years, if not longer. Some fish, like our pajama cardinal here, will live for decades, but really have very narrow windows of when they're actually spawning. Now, we can make thousands of this fish, but we do need a kind of constant supply of wild-caught fish to kind of keep things moving with that. Next to that, we've got the Bengay cardinal, which is an example of an extremely popular aquarium fish that's now almost exclusively available as a captive bred option. Wild-caught is really not something you would ever see anymore. This fish is raised by the hundreds of thousands in big fish farms in Thailand and Southeast Asia, but it's also listed as threatened and put on the endangered species list by the IUCN in 2016, solely because where its native range is very limited, but again, captive bred has really brought this fish into popularity. Some fish, however, like this is our McCulloch's clownfish, they aren't available from the wild anymore, and it would be impossible to start captive breeding them today. So this fish is only found on Lord Howe Island, which is very, very far off the coast of Australia. In 2008, a very few, I think less than 8 specimens were brought from like a one-time collection opportunity. One of those pairs actually started spawning. We collected the offspring, and now this fish is only available because of our efforts at captive breeding this fish. So if under any weird circumstance where we lose our brood stock or we stop raising this fish somewhere else, it's likely this fish vanishes from ever being seen again in the home aquarium or in real life, outside of just photographs or traveling to this very, very remote location. Nope. Back up a little bit. So I also had mentioned earlier how man reproduction posed challenges for ORA. So when this fish was first raised, it took over a year to raise this fish to a size that compared with marketing of a wild type fish. However, like I said, it had a dismal rate of survivability. Ours were twice the price, and that made a very big impact on our ability to sell this animal. Now, however, we can sell this fish at a smaller size, at the same price, and it's immensely popular because tastes have changed, and people really have a real big drive for aquacultured and captive bred animals. So what's next? ORA is going to continue to raise as many different varieties of fish and invertebrates and shrimp as we can for the aquarium industry. And that initial vision we laid out in 1996 of 100% captive bred aquarium is now fully possible within the aquarium industry. And whether you guys know it or not, aquarium keepers are stewards of the environment. They are in many ways functioning as mini zoos or arks, preserving species that are struggling in the wild due to increased water temperature or reef destruction. Aquaculture is an essential part of preserving our oceans and coral reefs, and it stirs a real passion to help people motivate these animals that may never ever get to have the opportunity to travel to these places in the wild. So the future of our hobby and our industry will depend on captive breeding and passionate aquarists, and ORA looks forward to being a part of that future. Thank you very much. We do some of that on our land farm at the market, but the vast majority of the coral we raise are for aquariums.
All right. Thank you, Jordan, very much for your presentation. Next up, we have Dr. John Schenker. He is a professor emeritus in marine biology and fisheries and aquaculture at FIT, Florida Institute of Technology. His presentation is going to discuss the mixed levels of success and associated significant ecological and genetic concerns of restoring finfish fisheries, such as cod, red drum, and bonefish. So please give a warm welcome to Dr. Schenker.
Good morning. Before I get started, I just want to ask all of you, if you have a chance to go to the Bahamas, go into a local bar or a pub, get a glass of Nassau Royale, liqueur, and raise a toast to Dennis Hanasek. And if you catch up with me later, I'll explain the story behind that, but he will be sadly missed. Okay, I'm going to shift gears. I'm going to shift from the ornamental trade to the food fishes of the world and talk a little bit about stock enhancement. How aquaculture can go ahead and, at least in theory, boost up the stocks that we're consuming for our own food. The basic idea behind stock enhancement is to try to increase the yield for the captive fisheries. This can be done partly because you're trying to boost up the size of the stocks you're eating, or it's to mitigate for habitat loss, habitat decline, basically trying to ensure that these stocks will persist into the future. When you're working in the natural environment, there's lots of trade-offs. There's lots of positive possibilities. There's also a lot of serious negative concerns that you have to be very careful to deal with. And so I'm going to talk a little bit about the history of stock enhancement or stock restoration, talk a bit about the a particular international program that is generating a lot of concern, and then focus in on what we're doing here in Florida. Fisheries enhancement, stock enhancement is not a new program. It's been going on for a long time. The oldest example that we have in the United States goes all the way back to the codfish. And for those of you from New England, know that codfish is a huge fishery up there, and it actually goes back to hundreds and hundreds and hundreds of years where the codfish fishery stimulated a lot of exploration from Europe into North America, perhaps even preceding the Vikings way, way, way back when. And the codfish were incredibly abundant. People were talking about basically walking across the backs of all the codfish in the Georges Bank area, the New England area. They thought there was an inexhaustible resource. The fishery built up on it really quickly, and by the mid-1850s, we were already beginning to see a really dramatic decline in the codfish fishery. That's a pretty significant change to the local ecosystem, the local market. And back in 1871, 150 odd years ago, the U.S. government established the U.S. Fishery Commission. And the first goal of the Fishery Commission was to try to reestablish the codfish fishery by setting up fish hatcheries, growing the codfish eggs, growing the codfish larvae, and then releasing the eggs and larvae back into the environment. They did this at a little location that had previously never been heard of before in Woods Hole, Massachusetts. And I think most of you know where this story is going. This first stock enhancement program led to the development of the Woods Hole Oceanographic Institute, the Marine Biology Laboratory at Woods Hole, and it's now also the center of the NOAA's Northeast Fisheries Center. So this particular species, this particular enhancement program, has led to some pretty dramatic changes in the way we deal with the world. One of the things they got at the Woods Hole Center was the fisheries research steamer, the Fishhawk. Built in 1880, it's an ocean-going marine fish hatchery. Had big tanks on the back deck, and it was working in Woods Hole on the codfish program, but it was also working on the American shad. American shad is a very important food fish back in the colonial America, the early 1800s. These fish would swim upriver to spawn, and the larvae would drift back downstream, and then they would grow in the ocean, go back upstream again. Well, back in those days, they're putting in dams everywhere to tap the hydropower. And by doing that, they blocked the American shad spawning migrations. So the Fishhawk was built as a fish hatchery to go from stream to stream to stream as a mobile fish hatchery and basically take advantage of each individual river's spawning migration and try to rebuild the populations that way. So, long history of restoration aquaculture. In terms of the world's biggest stock enhancement program, it's the Pacific salmon. Like the American shad, these guys are anadromous. They spend their lives in the open ocean. They swim back upriver to the stream in which they were born. They lay their eggs in the gravel, then they die. After the eggs hatch, it takes them perhaps a year or two, up to a year to develop into the smolt stage, by which point they're about this big. They migrate downriver, go out into the ocean for 3, 4, 5 years, swim back upriver, and start the cycle all over again. And so salmon ranching, they call it salmon ranching, developed basically to initially help the populations that were severely impacted by dams. Again, you put dams in place on the big rivers. Salmon cannot get up past those rivers to spawn. If they are spawning upriver, the babies get chewed up in the dams as they're going downriver. And so ocean ranching developed as a way to try to mitigate for a lot of that damage. It's also used for population restoration. Some areas have undergone such serious damage due to, damming, deforestation, clear-cut logging, water diversion for agriculture or human use, and now even climate change has caused some really dramatic changes to the fish populations, and salmon ranching is a way to deal with those changes and hopefully try to mitigate some of the problems. So this is a typical salmon ranching operation. This one's up in Washington. This is what a hatchery looks like. The females swim right back up to the hatchery. They view that as their spawning ground. That's where they were initially released. They're going to be dying within a couple weeks of laying eggs, so the eggs are harvested, sperm is harvested, they're fertilized. After growing the smolts for about a year, they're let go into the open ocean. They then spend 1, 2, 3, 5 years, depending on the species, out in the North Pacific before they migrate back upriver, back to the hatchery, where they can be harvested and either turned into human food or, in many cases, pet food, or also used to propagate the next generations. There is a lot of this going on. Salmon hatcheries around the entire Pacific Northwest Rim, from United States all the way over to Japan and Korea. Just within Washington alone, there's 100 hatcheries in Washington state, and they release about 200 million smolts a year. That's a lot of baby salmon to be put into the open ocean. Once this process started, particularly in the 1970s, by the mid-1980s, all of these countries were releasing about 5 billion, with a B, baby salmon into the open ocean every year, and that level has persisted since the mid-1980s. There's a huge number of baby fish being released into the open ocean, and it has been reflected somewhat in the catches. You can look at the catch history here. You can see that in recent years we're harvesting between 400 and 500 million fish a year, many of which are coming from the hatchery, the ranching program. This is incredibly controversial. There's a lot of benefits to it. In California, for example, some of the streams and rivers are so badly degraded that they barely are supporting a viable salmon run. There's been a lot of restoration efforts going to restore the quality of those streams and rivers, and ranching approaches is about the only way to reestablish those salmon runs back into those highly degraded but now being restored streams. When dams are blocking their spawning sites, this is a way to go ahead and try to keep those populations going. Incredible amount of money goes into that, and the populations still are not really thriving. It's a tremendous economic engine for all of the fisheries, both in the open ocean and in the hatchery fisheries, for the seafood processors, for the hatchery operators, and so on. So there's a lot of economic benefit going on. But there's also a lot of problems. One big problem is that when you release 5 billion fish into the North Pacific every year, you're swamping and outcompeting the naturally produced populations. There's a lot of interspecific competition going on. For example, Russia produces a lot of pink salmon, which is a fairly small salmon, comes back to the hatchery in 1 to 3 years. And we don't do a lot of pink salmon aquaculture or pink salmon harvest in the United States. We prefer Chinook or the king salmon or the coho salmon. But releasing all of these pink salmon is putting a tremendous competition for food sources for the fish that we prefer here in the United States or in Canada. There's also big genetic concerns. Salmon mostly go back to the stream where they were born, but there's a little bit of leakage. And so there's a fair amount of gene transfer now from the aquaculture population to the wild population, and a lot of concern of what that's going to do to the ultimate viability of the wild population. And this is expensive. There's a lot of money being put into the salmon ranching operation by the government, by private industry every year. And in many cases, it's probably not financially worth it, just purely from a fisheries point of view. A lot of it is being put in there from a mitigation point of view, saying, well, if we put these dams in place, we've got to put some money in to keep the fish going. So a lot of people, a lot of organizations are really focusing on trying to see if they can reestablish the wild populations as much as possible. One of the keys to this in many areas is dam removal, and then spawning habitat restoration to try to give these fish an opportunity to go back and do what they should be doing. These objectives are something that's far more than the salmon issues. The American shad, which are appreciated getting all the dams to their spawning areas removed, for example. And so this is something that's a really big issue all around the United States. And, well, over the last 100 years, over 2,000 dams have actually been removed. And most of these dams are low-head hydro dams in the Northeast, but through many other areas. And they're put in place to harvest hydropower back when a lot of our industry was dominated by small dams producing electricity or water wheels or other things. We don't need them any longer. So a lot of dams have been removed, but still, There are these big dams, especially on the Columbia River, the Klamath River, that are in the process of being dismantled or have been proposed to be dismantled. Tremendously controversial because you are going to have to replace the hydropower that is lost. You're going to have to replace the irrigation water that is lost, the ability to transport goods by barge. So there's going to be some big changes and big arguments in coming generations. To switch to Florida, let's go on the redfish. Curious, how many of you guys have caught redfish? Okay, pretty good number. Tremendously valuable sport fish. There was a commercial fishery for these guys up until the mid-1980s, and that commercial fishery ended. I'll talk about why in a second. The current populations are protected from commercial fisheries. They're just subject to recreational fisheries, but they still are affected by red tides. They're affected by habitat degradation due to a variety of coastal issues, ranging anywhere from seagrass loss to nutrient flow to water loss. Definitely stressed in many regions. What makes them especially suitable to stock enhancement is they are really easy to spawn and rear in the laboratory. And they do a fair amount of this right here at Harbor Branch for research on ways to optimize the commercial yield of aquaculture red drum for their own use. Because they're so easy to rear, it makes them excellent candidate for stock enhancement. I pulled together the fishery landings just to show you what the populations have been through. And if you look at the landings by the commercial fishery, back in the 1980s they exploded, and then they went to near zero when the fishery was basically closed to the commercial operators. Some of you guys probably remember this episode. Paul Prudhomme, the famous Cajun chef from New Orleans, invented a new recipe for blackened redfish. Ring a bell? Okay. That triggered a massive explosion in the redfish fishery. Most commercial redfish fishers back then were going after the small fish. The big ones were pretty coarse, not very edible. You put them in a frying pan at high heat with lots of spices, well, you can start eating the big guys too. So the commercial fishermen started going after what actually turned out to be the broodstock. When Paul Prudhomme found out what the problem was of his redfish recipe, he actually went up and gave a speech on the floor of the U.S. Senate and said, please regulate the fishery, close down the commercial thing. We'll find some other way to do a blackened fish for dinner. And so Paul Prudhomme was actually leading the conservation effort for this species. So you can see the commercial fishery died out, the recreational fishery went way up, and quite a bit of this is apparently due to stock enhancement. And this is done in states from Texas through Florida and up into the Georgia and South Carolina. Just a couple of examples. In Texas, there are 3 big coastal facilities that rear and release red drum, and it's run by the Texas Parks Department and also in association with the Coastal Conservation Association, which is a very, very active organization here in Florida and in the redfish issues as well. Since 1983, Texas has been stocking about 30 million red drum fingerlings every year. That's a lot of baby redfish being released. This net full here represents the 800 millionth redfish fingerling that Texas has released into the open ocean. This release, by the way, is an incredible attractor also for politicians. Every Texas politician tries to get a photograph of themselves sitting in waders or a pair of boots, spilling a net full of baby redfish into the ecosystem as an irresistible PR opportunity. And there's some great photographs of even ex-President George W. Bush, when he was governor of Texas, letting redfish go. And all I can say is bravo to everybody supporting a project like this. Does this work? Is this actually succeeding? Well, Texas has done a number of experiments showing that the contributions to the fishery vary tremendously from year to year. Some years, the redfish that are stocked do not do well. Other years, they may contribute up to 30% of the wild fishery, of the total fishery. So it can vary tremendously from year to year, from location to location. Here in Florida, our redfish research and stock enhancement was focused in on a facility in Port Manatee. This is run by the Fish and Wildlife Conservation Commission, and it's called the Stock Enhancement Research Facility. It's about an 80-acre site, included the hatchery here, where fish were held in spawning condition. They can control their spawning simply by dialing the temperature up or down. They can trigger redfish to spawn at their will. They would hatch the embryos out. While the embryos were hatching out, they went ahead and they fertilized ponds. They started off dry. They added some fertilizer to it, added some water to it, let the soup simmer for a couple of weeks, building up a plankton population. And when the plankton population is at the right level, they take the fry out of the laboratory, put them in the pond, and allow them to grow. Very, very productive, very easy, they got it down to almost a mechanical process. My favorite part of the hatchery, the surf hatchery, was the Spartina water filtration marsh at the end. Water has to be filtered and cleaned before it's released back into Tampa Bay, and so they built a Spartina marsh, probably 50 acres of it, and it was so productive that within a couple of years, they started having school groups and conservation groups come in, harvest the Spartina, take it and use it in their own marsh restoration programs around Tampa Bay, which is a pretty cool idea. The surf facility also focused on snook and sea trout and scallops and conch, but redfish was really what their primary focus was. They did more than just simply focus on the research. They did a lot of work on the trying to figure out how to optimize this. I'll summarize this really quickly. They wanted to look at phase 1s, phase 2s, phase 3s, figure out is it worth spending money on growing the little ones or spending a lot of money on growing the big ones. And they decided that growing the big ones is the way to go. They also developed all kinds of procedures for optimizing the growth and the function of aquaculture in Florida. They closed down surf a few years ago. It's been replaced by a newer facility in Apollo Beach. And so if you get a chance, they are offering tours up there. And finally, other organizations are involved. Duke Marine Lab, the Duke Energy Mariculture Center is working with CCA. They are releasing about 275,000 drum over the last 5 years. They are running a new operation right now. If you would like, you can adopt your own redfish. And it's $100 to adopt your own redfish. It'll be tagged and released, and you will be allowed to even take it and let it go. So it's a great fundraising opportunity. And finally, they also have catch a tagged red drum as a fundraiser. You catch a tagged red drum, that's a certain tag, and you can win some really large boats. The bottom line is, if you tie it in together with the fisheries regulation, which is more and more and more elaborate as time goes on, you can do a pretty good job of regulating the species. And it gets to the bottom line of aquaculture stock enhancement is a tool. If you can use the conventional approach or the optimal approach of restoring the habitat, restoring the conditions for fish to survive on their own, it's a great way to go. But if you got to open up the toolbox, and if you can figure out the right way to do it, aquaculture can be a very effective approach to dealing with fisheries issues. So I'll call it quits there. If you'd like to learn more about some work we're doing with bonefish, which we're not up to the stock enhancement stage, we hope not to get to, but invite me back in the future. I'll be glad to tell you that story. Thank you.
All right. So next we're kind of moving away from fish and into coral. So our next talk is going to be a virtual one. It's going to be given by Chandler Wright, who works with the Coral Restoration Foundation, which is located in the Florida Keys. She is the education and outreach coordinator for the foundation, and her presentation will focus on how the foundation uses aquaculture to save Florida's coral reefs and the importance of coral to Florida's environment and economy. So what this is going to look like is she recorded a talk for us. We'll play that, and then she also did some demonstrations of how they outplant coral. So then we'll play that as well, and then I'll come back up and release this for break. Enjoy.
Hi, everyone at FAU. My name is Chandler Wright, and I am the Education and Outreach Coordinator of Coral Restoration Foundation. And I've been an avid coral restoration practitioner for about 4 years now with CRF, and I am thrilled to be able to talk with each of you today in the audience. And I'm very sorry that I'm not able to be there in person today, but I would love to get my contact information if anybody has any questions afterwards. I'm more than happy to answer them. So, without further ado, let's start talking about corals. So, corals, they've been around a really, really long time. I'm talking about 500 million years, give or take. The first corals predate dinosaurs. They predate your favorite shark. They predate land plants, and they predate all your favorite fishes that we've talked about today. The planet, you could say, knew polyps before it even knew weeds. And they certainly predate us humans. And in that time, corals have survived a lot. They pushed through extinction events and natural cycles of warming and cooling, and they've taken thousands of years to adapt, overcome, and form what we call today is one of the most biodiverse ecosystems on this planet. Coral reefs are, and of course, made up of corals, which themselves are totally underrated. I mean, I know we're quite high intelligence in this room, being coral farmers and researchers and scientists, but as you know, ask the average person to think that corals are plants, animals, or rocks, and see what they say. The average person is actually quite unaware that corals are, in fact, made out of hundreds, millions, billions little animals called polyps. And they do build a mineral skeleton, which is the rocky part, and they do have tiny symbiotic microalgae that live in their bodies, the plant part. And these cute, funny, fuzzy little tiny creatures actually form together to create a strong foundation of a critically important ecosystem, so massive that it can be seen at times from outer space. These coral reefs. Coral reefs have a lot to offer humans all around the world. A healthy coral reef can dissipate up to 98% of a wave's energy before it reaches the shore, providing invaluable coastal protection to communities around the world. Coral reefs also support at least 25% of all marine species, or 1 in every 4 that you can think of. Coral reefs directly also provide sustenance and a way of life for millions of people around the world, not even counting the billions that also indirectly benefit, underpinning economies in the form of tourism and fisheries. Here's a fact that might blow your mind. Worldwide, coral reefs have an estimated value of around $10 trillion every year, which is a number that I know a lot of people in this audience can really appreciate. And these incredible, indispensable ecosystems are hidden just out of sight for much people, right below the waves. So this is a really beautiful story, right? However, what's the problem? We've lost at least 50% of our world's coral reefs in just the last 30 years. This is a biological, ecological, and economic disaster on an epic scale. But what's even scarier is that by year 2100, with no intervention, we fully expect that coral reefs could completely disappear from this planet. So let's let that sink in for a moment. Because I'm not just saying that we'll lose a species of 2 of coral, or when you're at a restaurant, us fish lovers might have to order a cheeseburger instead of our favorite grouper sandwich. No, I'm saying that an entire ecosystem and everything associated with it will disappear from this planet. And humanity has never experienced the loss of an entire ecosystem before. And if we don't work toward a carbon negative future and address our local impacts, then we will find out just what losing an entire ecosystem means and looks like. And I know this feels overwhelming, and I really just jumped into it here. But the reality is that we need large-scale massive action if we're ever going to save the world's coral reef. And around the world, scientists and researchers are working hard to combat coral degradation through a process called coral reef restoration. So, like I mentioned earlier, I work at Coral Restoration Foundation, or CRF, where we manage one of the world's largest restoration efforts on the planet, which is focused in Florida Keys. And as one of these organizations, here's what a typical day looks like. So we have divers propagating genetically diverse corals in the world's largest offshore coral nursery. This coral nursery is home to over 20 species of corals and more than 1,300 individual genetic variants. And once the corals in our nurseries reach reef-ready size, we take and move them in massive quantities to the reefs of the Florida Keys. And on these sites are scattered all the way from Key Largo down to Key West, and we're restoring wild populations of these important animals. Now, it all starts with the invention of the coral tree, like this one here in this picture. Coral Restoration Foundation actually developed this coral tree, and it's a simple but very innovative way to grow corals on a massive scale. So here in this picture, you'll see a lot of small finger-sized like corals. These are actually called staghorn corals, which is one of the endangered species indigenous to the Florida Keys. We're gonna do a little exercise here. If you look at this tree, pick your favorite coral in the tree for me. Keep your eye on it and look at it, okay? Everybody have one picked out in the room? My favorite one, I'm going to pick this little chicken foot one in the bottom left-hand corner. All right. Now, bam! What does your coral look like? This is just 9 months later. How is it looking? These coral trees allow massive growth of corals on a large scale. In just 6 to 9 months, a coral the size of a pickle can get to the size of a basketball. And since I know we have a lot of intellect in the room, I'll explain why. With these coral trees, they are productive for various factors. 1, the coral is able to hang suspended in the water column. This means that our coral gets 360 degrees of water flow, allowing our polyps to engulf a large amount of pelagic organisms for nutrients. 2, these coral trees are hanging in the middle, which means that they're getting sunlight from above and they're getting sunlight reflected from the seabed below. So this means that our important zooxanthellae are getting a lot of sunlight on a massive scale. And lastly, what's unique about these coral trees is that they are tethered to the seafloor using a duckbill mechanism and floats at the top. So this creates tension on a rope. And this provides the ability of our restoration team to actually raise and lower our coral trees dependent on environmental conditions. For example, in the summer, whenever the water gets really hot, we are able to go out to our coral nurseries and lower our coral trees down to the seafloor where it's a little bit cooler. In the winters, we might raise the coral trees so they may expose some more sunlight and a little bit more temperate waters. And also this comes into effect whenever we're facing large hurricanes and storms with big swells. This provides us with the ability to lower and protect our coral trees from waving around within the strong storms and turbulence of the sea. So these are efficient, smart, and are able to produce corals on a large scale. But it's not just one tree that we have, and it's not just a dozen trees. It's an entire football field worth of coral trees. Our largest coral nursery is at over an acre and currently houses around 500 trees and is home to over 30,000 corals. And it's not just one. We have multiple coral trees nurseries. We have multiple coral tree nurseries, and together they currently house over 45,000 reef-ready corals every year. So we know we grow a lot of corals, but the goal is not to just keep them in the nursery. We want to take them back out to the reef. Once the corals are big enough, we start by harvesting the corals from the nurseries. And we do this with a process called propagation. Some of you might know that corals are actually able to reproduce through a process called fragmentation. So our restorationists will go in the water, trim an arm off a coral, and once the coral arm is to the side, that arm will regrow a coral. And the coral which lost an arm will regrow an arm as well. So this provides us with the ability to multiply the corals and to fragment corals for outplanting while leaving some on the tree to grow more and reproduce corals for future outplanting trips. So we put these corals in these super high-tech milk crates onto our boats, and we go right to their forever reef homes. So we will send teams of divers up and down the Florida Keys to attach these corals to the reef using a non-toxic, marine-safe epoxy. And we attach these corals directly to the reef using an outplanting process. And we'll outplant the corals in genetically, we'll outplant these corals in clusters of genetically similar variants. So it'll actually increase the coral's likelihood of growing together and causing fusion and creating a healthy thicket. And this healthy thicket gives us one step closer of restabilizing reefs to create that 3D home for those fish and other marine creatures to enjoy in their marine environment. So with this way, we are covering as much reef area as possible while stabilizing huge swaths of reefs and creating a habitat and food for everything living on the reef and us humans on the shore as well. So it's not just 1 or 10 corals that we're outplanting per day. It's hundreds of corals per day, and that adds up to a lot. I meant to talk about this earlier, but whenever we're outplanting this coral on the reef, it's not just dilly-dally, 10 corals, we're done. I walk in thinking, man, it is arm day. I've got my energy drink in the morning, and we've got those hammers ready to go. So in 2021, despite its challenges, was actually one of our biggest years yet. We were able to outplant over 35,000 corals returned to the wild to the reefs of Florida Keys. So how do we know this is working? We have to keep track of all of this somehow, right? So returning the reef to a functional state also means having healthy corals, which makes us sorry about that, we lost connection for a second. Here we are. So what I was saying was returning reefs to a functional state also means that we have healthy corals to return to the reef. And what makes me positively giddy, what we see from our outplants, is that every year our corals are spawning. And here's an actual photo here of corals spawning and releasing their eggs into the water column. Now, this is months-long, energy-intensive process is important for the evolutionary reasons. But what makes us happy is a much simpler one. The fact is that our corals still have enough energy to reproduce after growing, catching food, fighting for space, and everything else that it means that they can't think that they are struggling to survive with. Amongst us all, they're thriving because reproduction is a very high energy-intensive process. And it's just not the corals in our nursery that spawn, it's those on the reef as well. So how do we know that this is working on a scientific platform? Well, we used to track all of these corals individually by hand in person with pencil and paper. And as you can imagine, paying every single coral a house visit got very, very energy intensive, especially when we're talking about thousands of corals a day. So now we track them using an innovative application of technology, which is very, very exciting and cutting edge. So what I'm showing you here is our process called photomosaic technology. We use a computer program to stitch together thousands of high-resolution images that allows us to visualize the reef through photomosaics. We do this before outplanting, after outplanting, years after outplanting. This way, we can see not only how the corals are doing, but how much area they are covering as well. And sometimes we capture more than just the corals on a camera, as you saw that stingray right there. And this is one of my favorite things to do after we outplant corals. We attach 2 GoPros onto a pretty ragtag PVC U-shaped pipe. With these GoPros, we swim along the coral reef in a lawnmower-like fashion. And this is how we capture those thousands of photos to be stitched together to render that 3D image just showed there. As of the end of 2022, Coral Restoration Foundation has returned over 210,000 corals to the wild. This is restoring an area of more than 34,000 square meters. And we aren't planning on stopping anytime soon. Along with the coral tree and other restoration techniques, our restoration methodologies are being taught and implemented around the world. We're also learning from other coral restoration practitioners, sharing lessons, techniques, and strategies for taking the work to scale. As we move to an area of biodiversity collapse and a runaway of climate change, working together is even more critical now, which is why CRF actually co-founded the Coral Restoration Consortium in 2017, where the goal of connecting restoration agencies and efforts came to a reality around the globe. And on top of this, Coral Restoration Foundation, we also do rescue missions. So a lot of times we'll get calls from construction agencies or rebuilding the bridge where they see corals which could be in danger. So our teams will rush out to these areas, gather these corals, protect them, take them to our nursery, and then return them back to the reef in a safe place. So I really want to thank you all for your time today, not only to share the process of coral restoration and coral farming, which you may not be familiar with, but also to inspire you guys that you too are connected to the sea, and corals and fish and our aquarium hobbies all go hand in hand, and we're all on the same team here. And I also want to close out by saying that if you have any interest in getting involved with Coral Restoration Foundation or dipping your toe in the water to see what it's like, we do have really amazing volunteer opportunities where you can come alongside a restoration team for a long period of time. Or if you just like to check it out for a day, we do have dive program opportunities too. We get to come with us in the classroom for the first half of the day, and then out in our nursery and in the reef in the second half of the day. And lastly, check out our careers website. We have a lot of awesome opportunities hiring scientists, tech specialists, restorationists, and educators for time in the near future too. So thank you all for your time today. Again, my name is Chandler, and my email address is chandler@coralrestoration.org. That's spelled like Chandler Bing. And thank you all so much for your time, and yeah, have a great day.
Hi everyone, it's Chandler again. So here is a life-size rendition of our coral tree. As you can see above, we have floats which are suspending the tree in the water column. And then below, we have a tether connected to an anchor, which is keeping the coral tree in a stationary spot. So as these corals are growing in our coral nursery, a lot of people don't talk about the maintenance that we need to do to tend to these coral trees to make sure that our corals are healthy. And I bet a lot of you can relate that a lot goes behind the scenes in your other fish farms and aquariums. So same thing applies here, is that what's important is cleanliness. So here we use two tools to clean our coral trees. Tool number one is our chisel. These are steel chisels that we use to clean the branches of the coral tree. So in our scuba gear in the water, we'll position ourselves at one of the angles of the tree and use this chisel to scrape away all the bivalves, algae, clams, fireworms that have started to grow on the branch, which can weigh down the tree. The other important tool that we use is our handy dandy brush. Yes, this is indeed a toilet brush, but in this case, we use it to keep our corals happy and healthy. And with this brush, this tool is specifically used to clean the monofilament line in which our corals are suspended. And with this brush, this is actually a really important step because we're cleaning away right here where the monofilament line connects to the coral so that algae and diseases and filth doesn't grow along the branches and down the line and potentially contaminate our coral. So we use these cleaning processes to keep all of our corals as healthy and happy as possible before we can return them out to the reef. Hi everyone! I wanted to show you how we actually outplant the corals after we grow them in our underwater farms. So picture this, it's a dive day. We just were at our underwater coral nursery and fragmented hundreds of corals. And now we're at the reef. So step one is picking out which coral you're going to outplant. Let's do this one here is my mood. So first step is analyzing the reef. When we have our coral in our hands, we are looking for a place of stability for the coral to connect. And as you guys know, as scientists in the room, what's stable usually? 3 points of attachment, like a tripod. So we will feel around the reef, measure it up, and see where would be a good spot. Here, we're pretty blessed with this nice plateau on the top. Step 2, we will get our handy dandy hammer. Now, these are the type of hammers that we will use underwater. It's quite heavy, around 3 pounds, I would say. But for demonstration purposes, I'm going to use this teeny tiny toy hammer right here. So underwater with one restorationist, we're going to look for those 3 points of attachments, and we're going to clear off around a Subway cookie sized amount of substrate and sand so our coral will have a clean slate to connect and grow. So I'll grab the coral with one hand and point to the point of attachment with another hand. And I know this sounds rudimentary, but after I personally have outplanted 900 corals, probably in a month in some summers, you gotta lose track. So it's important to point, lift, and then clear. And then we will put it back down. Measure, point, lift, and clear. And we're actually using the back end of the hammer, like so. And we're going to point, lift, and clear on that last spot here. And something to remember is right now, this is a simulation, but in the wild, sometimes when we're outplanting, you've got to deal with the surge, the waves, getting distracted by a nice little sea creature that swims by. It takes a lot of focus and balance and practice. So the next step is using our epoxy. So the epoxy that we use is a 2-part marine safe epoxy. And we'll mix it underwater in a large glob and distribute it to all of our restoration practitioners under the sea. And we'll take that epoxy and make 3 smaller little balls like this. And we're going to lift the coral point and attach that epoxy, making specifically a little Hershey kiss, or you could say volcano shape. And what's really fascinating about this marine safe epoxy is that over time, we'll actually see the coral naturally grow over the epoxy and make a natural connection itself within just a couple months of time. So now we have our 3 points of attachment. We are going to place the coral on top and make our hand in a pancake shape and evenly press the coral, even pressure across the entire coral. And we want to make sure to be really careful yet forceful here, because how disappointing would it be if we accidentally snapped one of the apical tips or the arms of the coral when we're trying to restore it, right? So we're careful yet forceful. And then now is for the final step. And this is my favorite step. This is called the wave test. So once we've outplanted all of our corals, we will hover above and we use our hands like this and literally pump a big wave of water on our coral. And we're doing this to check to see how good of a job we did and if this coral is stable. So we'll look, if it wiggles, that means we've got to do it again. And if it's stable, doesn't move, we can give ourselves a nice pat on the back, say, all right, we did a good job, and then move on to the other hundreds that we have planned to outplant for that day. And another fascinating part of our outplanting process is we will actually outplant corals in clusters of the same genotype. And we do this in order to increase the natural process of fusion. And this is when 2 corals will grow together, connect, and create that 3D structure, which is so important to increase reef stability and create that dynamic home for our fish and seafood and marine creatures that we love so much. So that was a little demonstration, and I know it seems like we use toy hammers here, but this is actually how we do it under the reef, and it's one of my favorite parts of the job that we get to do when weather permits. So, thank you so much. Really disappointed that she couldn't come talk to us in person and demonstrate in person, but I'm so glad she sent us those great videos. So now I'm going to release us all for a 15-minute break. Please, as a reminder, save any questions that you have for our presenters for the panel discussion so that everybody can hear them and they'll be recorded for the future. While you're taking your break, feel free to run to the restroom, get some water. You can step outside if you would like to get some warm air, but just don't stray too far, and I'll see you all back here in this room at 10:55.
She's a very outreach person.
She is, yeah. She's an educator through and through. So we hadn't even completely been able to watch it because we got it like at this morning, like 7.
Hello?
Ah,
Yeah.
okay, perfect. Perfect. So yeah, so we got it.
All right, everybody. It is 10:55, so we're going to get right back into it. The next presentation is going to be given by Dr. Megan Davis. She is a research professor and faculty member here at FAU Harbor Branch. Her presentation is entitled Queen Conch Conservation Aquaculture in Florida and the Caribbean. Dr. Davis is the world's leading expert on queen conch aquaculture. Today's presentation will highlight how FAU Harbor Branch Queen Conch Lab works with local communities across the Caribbean on conservation projects using aquaculture techniques. Their current objective is to raise queen conch for restoration and small-scale hatcheries, which include stationary and mobile labs. I worked with the Queen Conch Lab for 4 years and greatly enjoyed it. I'm sure the Queen of the Sea will inspire you to fall in love with queen conch like I did. So everyone give a warm welcome to Megan.
Okay, good morning, everyone. The middle one, right? Okay. All right. Well, it's been an exciting morning already, hearing about all the different restoration projects going on, both here in Florida and also really around the United States and the world. So today, as Laura mentioned to you, I'm going to talk with you about the queen conch, also known as endangered gigas. And let's get started. So the queen conch is such an important species throughout the Caribbean and also in Florida. It's truly a way of life in the Caribbean. There's whole communities that are put in place or developed in those communities because of the queen conch itself. It is the most important molluscan fishery species in the Caribbean, and it's only second to spiny lobster in terms of fisheries quantity that's fished in the Caribbean. In case how many of you have had conch or been to the Bahamas and eaten conch? Okay, in case you haven't, The queen conch, here you see the shell. This is the parts of the animal that come out of the shell. This is the actual foot that's eaten. And then this is the intestine here that swirls up inside of the conch. In fact, this orange part here is called the mantle, and that's what the conch uses to form the shell. And then the skin here comes off the meat. You have the operculum, which is like the little trap door, and then the eyes there. So it's about, I don't know, there's about 4 or 5 conch for every pound. And so that's the piece of the meat that is eaten. And here you see it's made into a conch salad. That's the most popular way that conch is eaten. Also conch fritters, as you can see here, cracked conch soup, and so we consider this species what we call a pan-Caribbean species, because it's found, as I mentioned earlier, it's found throughout the Caribbean. And that's a very important aspect when we think about how it is interchanged throughout the entire Caribbean. So it has a larval stage that I'll tell you a little bit more about that drifts in the open ocean. And so the Caribbean is a very interesting place because it has maybe 30 different countries and different territories in the Caribbean. And every one of those countries has a different set of regulations for the species. So you can see the range of the species is throughout the Caribbean, also Central America, and also on the southern coast of, or actually I should say the northern coast of South America, and then all the way up to Bermuda. And you can see that it also goes along the Florida Keys, and up until about, I suppose we've seen it as far north as St. Lucie Inlet would be about as high up as it goes here in Florida. So this is why we call it a pan-Caribbean species, because it's throughout the entire region. But as I mentioned, there's different regulations in every country. And so one country's regulations may have an effect on another country because the larvae can drift up. So the conch know no boundaries, but the regulations have the boundaries. So it's something to keep in mind when regulations are made. So this is what's called a CITES II species, which is the Convention of International Trade of Endangered Species. And on Appendix 2 means that it can still be fished, but it has to be fished with management regulations and a sustainable fisheries management plan. And so the majority of the countries do follow the CITES. But I also want to let you know that it recently became listed by NOAA Fisheries as a threatened species under the Endangered Species Act. And so they've been studying this for 10 years, and they just made this announcement just a couple of months ago. So there's no regulations that go with this yet, so everybody's falling under CITES II. And over the coming years, what will happen is they'll start to put a recovery plan together, and the recovery plan will help this species not to reach the endangered species list. So I don't know if you know, but in Florida, there's been a moratorium on fishing conch since 1986. And some of the conchs are definitely starting to come back in the Florida Keys. It's not likely that they'll open up the fisheries again, but it's very wonderful that the conch are starting to repopulate the areas. And so let's talk a little bit about the biology of the queen conch. The female has an egg groove that runs down the side of her foot, and then the male has a verge. So it's very easy to tell them apart if they come slightly out of the shell, you can see it. But also when they're in their copulating position. So they have internal fertilization, and then you have the female is here. The front of the conch is where the eyes come out, and then the male comes behind. And so it's this time of year that they're copulating. They'll be laying eggs and mating throughout the warm summer months. So from about April until about September or October. And then the female lays an egg mass. She lays this mass underneath her lip. And it's about 500,000 eggs, which sounds like an amazing number, which it is. And she lays 10 of those a year, which means she's laying close to 5 million eggs every time or every season, which also sounds like a lot of eggs. But as we know in the wild, only less than 1% will survive. And so here she lays the eggs, and then when she's done laying, she leaves the eggs on the bottom of the ocean. And they incubate in the bottom of the ocean for 4 days. and the currents are going past them. And then in the evening hours at around 9 o'clock at night, the little veligers come out of the egg mass and they float with the currents. And they'll be in that stage of a veliger or larvae for about 3 weeks. This is what the eggs look like when they're just ready to hatch. And you can see that they're spinning in their egg capsule. What I want to note to you is that those white things that you see there are sand grains. So this shows you how tiny the conch is just before it's ready to hatch. They have the orange pigment you see there is their foot developing, their lobes that they use for swimming. You can see the 2 eye spots. And then this is their shell here. It's the same exact shell that they keep their entire life. And when they're in their embryo stage, they're developing an egg yolk, which they hatch out at. And so here's the night of hatching. And it's very exciting. Last night we had a big hatch in Puerto Rico hatchery. And this is what was happening in the evening hours. And then they look like these beautiful little veligers with their swimming lobes. And you can see their shell. Their lobes are used for, as you can see, for swimming, but also for respiration and for collection of food. So they're a herbivore and they eat microalgae. And as they get a little bit bigger, about 4 to 6 days old here, you can see their shell has developed more. And in some cases, you can see the what we call the golden gut, which means that they've been eating their phytoplankton. And then this is about 10 days old, so they've developed yet another set of lobes. And I don't know if I can play it again. And then their shell is also elongated, and now the foot has gotten bigger. And then this veliger is almost 21 days old, and it's close to metamorphosis, or competency for metamorphosis. It's got these very elongated lobes, so it looks quite big on the screen here, but really it's only 1 millimeter in size. If you think about a pin that you use for sewing, the head of the pin is about how big they are at this size. And they've got a fully developed foot there. They're starting to develop their proboscis, and you can see their eyes and their tentacles really well. And so they're getting ready for metamorphosis, which is what happens here. You see it eats algae its entire life. It's a vegetarian or a herbivore. And so it goes through metamorphosis by finding a cue in the wild. In the wild, it's their seagrass beds because that's where they live. And they're a very important species to keep the seagrass beds healthy, as Jim was telling you earlier. And so they'll find the cue in their natural environment, but we bring it into the lab when we're working with them. About 5 hours later, they'll absorb their lobes, and then they'll be crawling like this little benthic snail here. Little conch, so cute. And then it takes about a year for them to grow to this size, which is about 7 to 9 centimeters. So just to give you an idea of their growth, the smallest one there is about 4 months up to about a year, and then a year and a half. We have a 2-year-old conch here, 2.5 years, just starting to begin that flared lip. 3 years, they have a very fine, thin lip. And then in the middle there, they have a more mature conch with a filled inlip, so they're about 4 to 5 years old. That's when we recommend harvesting because they've had a chance to reproduce. And then at the very end there, we believe they live to be about 40 years old. They have lots of predators in the wild. They're a very important part of the food web. When they're veligers, they're food to all different kinds of zooplankton and little fish. And then as they start to settle and go into the benthos, they have a number of different predators, from the spiny lobster to different crabs, and then the loggerhead turtle, the octopus. Before, in the Bahamas, Laura and I found that conch being eaten by an octopus. The porcupine fish, the eagle rays will eat them, and then also some of the carnivorous gastropods like the horse conch. But this is amazing. This is a nurse shark. Watch this. amazing. There's a researcher, film videographer, Duncan, who sent this to me, and I always had heard that nurse sharks could eat the conch, but I had never actually seen it. And so he filmed this in slow motion, and it's really quite extraordinary, the power behind the nurse shark and being able to suction out the conch. So you can see that the conch's a really important food species in the food web. Yes, isn't it incredible? So I want to tell you a little bit about the work that we're doing here at Harbor Branch. We have a vision to have a queen conch farm in every Caribbean country for restoration purposes. And right now, you can see our current projects. Here we are in Fort Pierce, and we have 3 projects in the Bahamas. We're about to launch a project in Turks and Caicos. We have a project in Puerto Rico, and then 2 satellite projects that we're starting up in Puerto Rico. Also Jamaica, down in Curacao and Bonaire, and we're starting to also work in St. Vincent, Grenadines, and St. Lucia. We've had other groups in the islands that are very interested too in having a conch farm, and then we've had a couple past projects in the Caribbean as well. So it's a very exciting time to be working with conch. I've been working with conch for almost 50 years now. And so it's very exciting for me to be able to share the technology throughout the Caribbean with our team members. So when we go into the different countries, we have to think about a lot of different things that we're working on. And our mission is to work with the species itself, to grow the conch for the species itself. Also for the ecosystem, we talked about the importance of it in the seagrass beds. And then also for the people that depend on the fisheries. And so we keep a lot of these things in mind as we go into the countries because, of course, we don't live there. So it's really important that we develop very strong people and community partnerships, that we also work in terms of fisheries and aquaculture regulations, and then taking the whole species and ecosystem into effect. And then we also have to do quite a lot of either fundraising or grant writing in order to do these projects. And so community really is the base of all of our projects. We wouldn't be able to do the work if it wasn't for the community embracing us to come in and work with them to do the work. And we also get to facilitate some exchanges that happen too, such as our Puerto Rico and Bahamian community collaborators coming together for a fisherman exchange. So I'm going to talk with you about our Puerto Rico project. I actually just landed back from Puerto Rico yesterday afternoon. I was there for 2 weeks working with the team there. And our facility is located in the Guabo and in a fishing community, right in a fishing association. And so it's very generational. Here's the president, Carlos, with his father. And then you see in the middle here, that's Julio. The fishermen help us by collecting egg masses and also working in the facility. Julio brings in the eggs, but so does his sons, Orlando and Jonathan. And then Orlando's wife, Marie, works in the hatchery, and so do their children sometimes come in and work as well as interns. Tonita over there, his daughter, Shirley works in the laboratory. And she's also a fisherwoman. So you can see that it's a truly integrated community-based project within the Fishing Association. And this is inside our hatchery. The hatchery is very small. It's only 18 feet by 8 feet. And it was fishing lockers. And the fishermen said, you can have these fishing lockers. There's 26 fishermen there. And they said, we're not using these lockers. So we took the walls down and we established a conch hatchery here, which has the larval tanks, it has the egg mass area, the metamorphosis, the algae area, and that's what the eggs look like when they're incubating. And then outside of the hatchery, in the same area, we have a nursery area, and that's where we have our juvenile conch. And we also make the food for them made out of ova and that we grow here at Harbor Branch, along with some chow ground up and some gelatin, and then we make it into cubes, and the conch eat those. And there's some of the partners and the staff there. We often have interns. So we've been in operation now there since 2019. We're funded through the NOAA Fisheries, also USDA and Puerto Rico Sea Grant. And then I just wanted to tell you a little bit about one of our restoration projects that we're scientific advisors for, and that's in Bonaire. So the conch that were grown in Curacao at the Queen Conch hatchery there have now been transplanted into Bonaire, and that's also a joint project with many different organizations and the fishermen there. And then our newest work is with mobile hatcheries. So we decided if we're going to move into these different places in the Caribbean, we needed to find a way to be able to have a hatchery arrive there, already ready to go. And so the first one that we built is in Great Exuma in a small community town called Roll Town, and it's in collaboration with the Bahamas National Trust. And since this time, we now have 7 more mobile labs that we've been building. We have one in Jamaica, and we have 2 that are going to Puerto Rico soon. We have 2 in Grand Bahama, 1 staying here, and it will eventually be part of the tour as you go through and tour Harbor Branch. And let's see and then another one's going to Great Exuma, so they'll have 2 hatcheries there. So we've been building these or installing these at Harbor Branch here in our machine and fabrication high bay area. They take about 6 months to a year to build. So we have a local trailer company nearby, and then we put all the tanks and all the plumbing and everything inside. And then to go along with that, to be able to spread the news, we also have a program called eConch, which is about to launch this month, that has all the different modules on how to grow conch. And these are some of the teams from around the Caribbean. And this is the team that helps make it happen behind the scenes. Assistant Director, Operations Manager. He's actually, Robinson's down in Puerto Rico right now. Amanda's here in Florida. Our engineers, advisors, and research administration. If you're on Instagram, we're Queen Conch Lab, and you can follow along on the types of work that we do. And with that, I want to thank you.
All right. Thank you, Dr. Davis, for that. It's always so exciting to hear updates on your work. Our next and final presentation is going to be virtual as well. This is going to be given by Hope Leonard. She's from Brevard Zoo. Her talk is titled Engaging the Community in Oyster and Clam Restoration in the Indian River Lagoon. Hope, a Florida native, is the Conservation Restoration Coordinator of the Restore Our Shores program, which is administered by the Brevard Zoo. Hope and her team use aquaculture techniques to restore clams and oysters to improve Brevard County shorelines. Today, she will share about the ecological importance of bivalves, the program's evolution and successes, and what they plan to do in the future. So with that, here's Hope.
Hello, my name is Hope Leonard, and I am here to talk to you today about how we have been engaging the community in oyster and clam restoration in the Indian River Lagoon for almost 15 years now here at the Brevard Zoo. And so when we think about the Indian River Lagoon, we think about some of these issues like stormwater with excess nutrients causing algal blooms. So with that, we go into the eutrophication cycle. So what happens when we get all these excess nutrients into the lagoons? And how does that affect wildlife? And so we get these excess nutrients, the algae, those little plants just absorb it and grow and grow and grow until they reach a breaking point. And as they're growing, they block out seagrass. And so there's less seagrass in the lagoon. And then as they start to die off, they actually are broken down by bacteria that respire just like we do, just like fish do. And those bacteria actually suck all of the oxygen out of the water column as they're breaking down the dying algae, which causes the fish kills, and then it decreases wildlife. And so that is what's been happening with these sequence of algae blooms in the IRL. And what are we doing right now to try and stop it? So I'm going to talk to you now about Restore Our Shores and how we really got started. And so we actually started helping UCF restore oyster mats in Mosquito Lagoon. And with that, we were doing such a good job up there with them that Brevard County actually approached us to start restoring oysters here in our own backyard. So right here in Brevard County. And that is what happened for our oyster gardening program. And so they wanted us to start growing oysters to seed oyster projects in the future. So we did that. We have over 1,600 people trained in Brevard County right now to grow oysters off their dock for us to then seed onto oyster reef projects. And so in 2016, we really started oyster reef building at a large scale due to the Save Our Indian River Lagoon project plan. So the sorrel tax is a tax that was voted upon by Brevard County citizens and helps Brevard County to actually afford to do restoration here and stormwater mitigation here and save the Indian River Lagoon. And so some of that money goes to restore our shores and to do some oyster restoration. And with that oyster restoration that we've been doing for almost 10 years now, we actually have expanded what habitats we actually impact. And so we started doing clam restoration in 2021. And then we've also expanded into seagrass now. And so we have 2 seagrass nurseries, one down near Melbourne Beach and the other is in Rockledge, Florida. And so with that, why do we want to restore oysters? What ecosystem services do they provide? So oysters are a gregarious species. They grow on top of each other in a reef-like structure, and another oyster is an oyster's best friend. So they don't want to land and grow anywhere else other than with other oysters because they are a spawning species. So like most bivalves or other two-shelled organisms, they actually release their gametes into the water column and they have to meet. So the sperm and the egg have to meet in the water column, and if they're not right next to each other, nothing's really going to happen. And so that's why they grow in these large structures. And so a lot of filtration can happen on an oyster reef when you have thousands of oysters per square meter. And so with that, they also create, these large structures also create a ton of habitat. So small shrimp and small gastropods and crabs and hermit crabs all live along these oyster reef, as well as some amazing species of fish and fishery species like stone crab and blue crab. They also allow for shoreline stabilization, so these large structures also help to prevent erosion and can help to create even just some banks behind them, some sand banks behind them. And then nutrient removal. So as oysters filter out algae and eat algae, that nutrient composition is actually immediately removed from the water column. Through their digestion, they convert the inorganic nitrogen to organic nitrogen, which can then be broken down by bacteria and released as nitrogen gas and put back into the atmosphere where it belongs. And so before I get into talking about some of our methodologies with oyster reef restoration, I'm going to talk a little bit about subtidal versus intertidal oyster reef. So subtidal oyster reef is when the oysters are below the water for their entire lives. So subtidal here in Brevard County, the only tidal influence we have is Sebastian Inlet, which is way at the southern end of the county. It's actually our southern border. And so we have a very small tide here, almost 1 to 2 inches, barely noticeable. And so our oyster reef up here really doesn't ever get exposed. And so that is something you have to think about when you are creating restoration materials. While intertidal reef, like a Mosquito Lagoon, St. Augustine, and Savannah, is open air for certain periods of the day because the tide has gone back and exposed the oysters. So very different habitats. So with that, the oyster mats that are used on intertidal projects really just didn't work in the lagoon. They got sedimented, they got blown around, they didn't have enough substrate to really grow the amount of oysters that we wanted. And so we started using oyster bags. And so oyster bags were this aquaculture gauge mesh filled with oyster shell, because oyster shell is what oyster larvae are attracted to, because an oyster's best friend is another oyster. And so they essentially, we would line them up in an oyster bar structure, and then 2 on the bottom, 1 on top, kind of like a pyramid. And this essentially allowed for us to prevent some sedimentation from happening on top. And then with that, we did see some limitations with these, though. They are made of plastic, so the oysters themselves are living razor blades. So as the wave energy would pick up in certain areas, at high energy areas, they would break apart. And so not the long-lasting material that we really wanted to stick with, which is why Restore Our Shores started to look for other things. And so while we were on our look, we actually came across these gabions, and so we started to build with this gabion metal. So the gabion metal we use is a 14 gauge steel wire mesh that is essentially formed into a box, and then in the same structure like bags, create a pyramid, except there were 3 on the bottom and 1 and 2 on top to create the same similar structure as the bags. And so with this structure, we actually saw the holes in the mesh for the bags were slightly smaller. And so we've seen larger oysters in here. And we've also seen oysters essentially staying in there and living on the reef at larger sizes due to the less restrictive area of the bags. And so that's very exciting, which is what has made us kind of switch from the bags to gabions. So we had a site that we compared them directly, and they actually had larger oysters, and also the mean density after 2 years was significantly higher in the gabions than in the bags. And so with that, the gabion metal is very expensive. And we're also still using, it's still metal, and so it is degrading over time, but we didn't want to have to use a ton of metal. And so with that, we created a corral-like structure, which is essentially gabions that are a little taller, that are formed into a fence, and then the middle is filled with loose shell. And the gabions are only really acting as a fence, and then the loose shell in the middle is going to create the oyster reef. And so with that, we've actually been seeing very positive results. We're very excited about our results with this. So we've seen that they, after 1 year at a site of having gabions in the pyramid style versus the corral style, they have very similar oysters, oyster density. So we see here that they're very similar. And so we decided to switch from using all that metal and having that large expense to the corrals, which have use less metal and put less inorganic materials into the water. So very exciting. And then we have even tried recently to get away from all man-made materials. So we put out our first test site for this in September of 2023. So we are using coquina as the walls of the oyster reef instead of the gabions in the corral method. So we're using coquina corrals to try and create a oyster reef structure, and we're very hopeful. We're very hopeful for this. So crossing our fingers that the gabion corrals and the coquina corrals are performing very well together. But at our 2-month test site, we actually saw that the gabion control had a lot of oysters, but they are still showing thousands of oysters per square meter in both methods. So we're very hopeful that the corral coquina and the corral with gabions are going to still perform extremely similarly with the gabion method. And so with that, we really learned through this process the importance of site selection. You can't put an oyster reef in an area where there's no larvae available in the water column to create that oyster reef structure that you want to call that oyster reef a home. And so with spat monitoring, or the monitoring of larvae in the water column throughout Brevard County, we've really been able to narrow down where we would like to build oyster reef, and through that we've gotten more successful with our projects. And so also looking at parameters like distance to shore, depth and flow, and sediment type, these are all very important aspects of choosing a restoration site. And so in the future with oysters, we're actually going to be putting out a 3/4 of an acre of corral projects planned in 2024. So very exciting stuff. Some of that went out actually last week. Very exciting. And then we're continuing to monitor gabions and corrals for long-term sustainability, making sure that this material switch is the best move overall for creating beautiful oyster reef. If you look here in this video, though, this is the video of a oyster gabion site that we use to compare the bags to down in Melbourne Beach, and you just see some beautiful natural oyster growth over here on the left. So now let's switch into clams. And so clam restoration, so the clams that we have here that we plant here in the IRL for restoration purposes are Mercenaria, or Northern Quahog hard clams. So what you would get in your pasta linguine. And they range from the Gulf of Mexico through the northeast of America. So the same clams you would go clamming with your grandfather in northern New Jersey for, they would be the same clams. So they do prefer a salinity between 20 and 35 ppt, and they spawn in the summer months with a growth period of October to April. So with that, the same thought process with oysters is with clams. So clams are a free living species, so they don't congregate by attaching themselves to each other like oysters do, but they live in essentially similar areas with mass numbers to allow for spawning to occur. But as they filter out algae, and they actually help to promote this nitrogen removal just like oysters. And so with that, to try and restore this species, we actually partnered with UF Whitney Lab, and St. John's River Water Management District actually gave us a grant to pursue a pilot study for clam restoration in the northern portions of the IRL, Brevard County in particular, and parts of Indian River County. And so 8 million clams were provided by UF, and then 100 sites were chosen all the way from Mosquito Lagoon to Wabasso Causeway. A volunteer force to help care for these sites was trained by Restore Our Shores. Seagrass was planted at 10 of the 100 sites by Florida Oceanographic Society, and then the monitoring of these sites was performed by Restore Our Shores. And so when we were looking at sites and our site selection criteria, we really did want a salinity minimum at that area of 15 ppt, because after a certain salinity, the clams start to not thrive anymore, and they'll actually close up and not open until the salinity gets higher, which can be never in certain sites. So certain sites near tributaries, things like that, where fresh water was flowing continuously, we decided to stay away from. Sediment type, we wanted some coarse sand or even just less organic sand for our clam beds. We avoided potential obstacles, and then we wanted a water depth from 0.5 meter to 1.5 meters. And so through this, in August of 2021, we did site surveys, we trained the volunteers, we went out and we put out the clams in October, November, and then we did winter monitoring in January to February. April to June was spring monitoring, and then summer was project wrap up, and then fall we went out and made sure we collected all the materials from the project. The volunteers really made this actually work, so almost 3,000 hours of volunteer time were dedicated to this program, because it's 100 sites, and so without them caring for these clam beds, we never really would have been able to do it. So thank you to them, little shout out. And so with that, the biggest issue that we had with clams in Brevard County was predation. And so anything that has a mouth seems to eat them and love them. And so when the protective net covering that you saw in the last slide when we were putting out the clams, so it was covered by a 4 millimeter mesh, was, if it came off, they were predated upon relatively quickly. If you look over to the left at this table, the median number for where the net came off, and looking at that survival, it is 0.05. So 5% was the median. And then the median of when the net stayed on was 0.45. So that's 45% survival versus a 5% survival. So predation was a large issue, and that was statistically significant. But this is what clam shards look like. So that's an evidence of predation as well. But for the most part, we for this study, we used whether or not the net was off or partially off when we arrived at a site for monitoring. And so with that, what else could have affected clam survival? So the only other parameter that was significant within every monitoring cycle was salinity. So lower salinity saw lower rates of survival. So if you look here, the Banana River Basin had a 0.55% survival with an average salinity of 24.75, and then highest was Mosquito Lagoon with 57, or essentially 57.5% survival, and then 30 was the average PPT. And so with these numbers, we essentially assumed that survival was related to salinity, and low salinity was not great for the clams. And so with that, we've started clam gardening. So like our oyster gardening program, we have used some of the previous sites that are in Brevard County and funding from our Save Our Indian River Lagoon sales tax that Brevard County oversees to start helping to restore these other filter feeders. And so with this program, the goal is to kind of raise 1 million clams at 20 previously successful clam pilot sites, alter the methodology from lessons, so to ease outplanting. So we wanted to be able to actually grow these out and then put them in areas in Brevard County where we believe the clams will thrive. And then goal is just engage the community to help to grow clams from a smaller seed for a better price, because larger the clam seed, more expensive. So hopefully we could get them big enough to where they wouldn't be predated upon as easily, and then we could outplant them in areas in Brevard County. And so with that, the 2023 results are a little brutal because the 2023 year, this El Nino year, has been very difficult in the central Indian River Lagoon. So the areas that we picked from our previous, for our gardening sites, were from the previous pilot sites where clams did really well. Mostly southern Brevard, where the salinity is pretty stable because of that inlet. And we actually saw extremely low salinity due to, in this region, due to the rainfall and also some extreme heat, which is very stressful to clams. And so we actually saw a very low survival rate, which is unfortunate, but it is what it is. But we know why. So here is the dissolved oxygen. We also had some algae blooms in the area, so we also had some dissolved oxygen issues. So thank you to Florida Tech and some of our Restore Our Shores sensors, DO sensors, we actually caught some of that. And so you see these red line in the red highlighted area, which is the Sebastian algal bloom. So you can see the algae is producing all that oxygen, and then you see it start to really dip at the end of the Sebastian fish kill. And then you follow the Malabar line, which after the Sebastian fish kill, if you follow that green line, you see the oxygen slowly decreasing and getting very low on August 9th of 2023. And so that is what killed a lot of the clams in that region as well. And so with that, in 2024, we are pushing forward. We are materials testing. So we're seeing if those bags that we had the little clams in were really the best material to use for growing clams and outplanting. So we're actually going to be testing and comparing them to 4mm bag mesh and 4mm cover nets, like similar to the cover nets that we used in the pilot project. And so with that, we're actually using bigger clams, so slightly bigger, more like 5.5 to 8mm versus our 3mm clams that we planted the previous year. We're hoping that if they're a little bit bigger, they'll be a little hardier and able to withstand some larger ranges of salinity and other impacts here in the IRO. And so with that, I just want to acknowledge all of our funding sources and some of the amazing people that have really made this work possible. And then also keep up with us. So if you ever want to figure out what we're doing, let us know. But I will say, I'll end on this. So restoration is always evolving. And so that's what we try to keep doing. Our methodologies and our materials, we are always trying to test new things. figure out what is the best possible way to be doing what we are doing. And that is really the only way to do amazing restoration work, is to be ever evolving, just like the conditions of the Indian River Lagoon and the ecosystem around us. So have a great day.
Testing. Aha. All right. Okay. So now this is the part of the morning where we have our Q&A panel. So if all of our presenters could please make their way to the stage. While they do that, I just wanted to let you know that you guys do have some opportunities to see some of these specimens that we've been talking about all morning in real life here on campus. You can do that by going to the Ocean Discovery Visitor Center, which you probably passed on your way in. There we do have examples of aquacultured seagrass. We have an entire 100% aquacultured tank with that has been sponsored by ORA, so it has ornamental species. It's very beautiful at the Visitor Center. We also have a large display on queen conchwork and more. So are we missing a prisoner? Yes, where's Jim? Okay, well, I'm not sure where he went. Please check out the Visitor Center. We also have a tour that's running this afternoon, but also runs throughout the week as well. And during that time, you get to drive by the ORA facilities and throughout our aquaculture park. So I'm sure Jim will join us in just a moment, but I'm sure you guys have lots of questions for our other presenters. So I will moderate. Just raise your hand and be sure to speak into the microphone so that your question can be saved for the recording. So I think there's a question over here.
I have two questions for Megan Davis. Firstly, I was interested in the conch food that you prepared. Is it available commercially, and if so, where could it be purchased?
The conch food, thanks for your question first. The conch food that we make is made out of dried ova that we grow here at Harbor Branch as part of our IMTA system. And then we work with Ziegler, who produces feed for shrimp, and we grind that up. It could also be a fish feed, and then we add gelatin. So we actually make it ourselves, so it's not commercially available, but the recipe is public knowledge.
Okay. Also, another question for you. Is there a resource for the private sector to hire your students that have successfully bred conch?
Breeding conch in captivity?
Yes.
We have bred conch in captivity, 4 different species, and right now we're currently breeding milk conch in captivity.
Is there a resource to hire any of the students that have successfully done that?
I'm not 100% sure your question. Hire people to do that. No, we can, well, I don't have anybody available right now. I need them all. But we can certainly help you get set up.
Thank you.
I have 2 questions also. Megan, when you showed the map of your projects, what is a closed project?
A closed project like St. Eustatius is when we completed a project with the team there. Okay. And so they had a specific research that project that we were doing. And we also had another one in the Bahamas that when the funding closes and we complete the project, then that's a past project.
Okay, thanks. And Jim, does the seagrass replacement project keep up with what the manatees eat?
It does not at this stage. Everything as far as transplantation projects in the lagoon are all pilot projects. And right now there's a shortage of identified sites. There's permitting that's involved. No, not even close to what the manatees are looking for. They're going to eat 100 pounds a day plus of seagrass.
They're big eaters. Do we have another question? Here,
question about the seagrass project. What kind of sites are you looking for?
Sites with water clarity, first and foremost. So there's a lot of really complex sediment chemistry, but the seagrasses are pretty good self-mediators. Once you get some fragments, some propagules, they start to modify their own habitat. They're a bioengineer species, and they create that habitat. But without the clarity, if you don't have light penetration to the seafloor, you're not going to have those photosynthesizers surviving.
Okay, will you take a look at sites for that? I mean,
oh yeah,
I have property that I'd like to put seagrass.
You might be able to get a consultant to look at a site. We don't have anybody who is in the habit of going out and looking at private sites.
Okay, thank you.
Other questions?
This one for Jordan. What species do you, or I guess types of fish, really don't take well to live or to artificial growth and growing them out? I'm sort of thinking about surgeon fishes and other popular types of fish. What doesn't work?
So, to my knowledge, there's certain basset species that, as juveniles, have very long filaments that take up a lot of space, that get damaged very easily, and that makes them very difficult to aquaculture. Some animals, like cleaner shrimp, may have very long larval stages, which makes it very costly to produce. Cleaner shrimp, for example, could be up to, I think, 100 days. Very long time. So those are some of the limitations that you're going to see with some of the more challenging species.
Gotcha. Thank you.
So I have a really general question for all of you. And we've heard about the restoration, like the coral restoration efforts, and how the coral could become extinct by 2100. And so my question is, what efforts can be made to deal with global warming, and what are some examples of ways that you can overcome the damaging effects over time, so that entire ecosystems don't go extinct by 2100?
There's a lot of genetics involved there. I wish that one of the coral folks was here to answer that question. But looking at the genotypes and looking at corals that show natural ability to withstand diseases. There's a whole litany now of coral diseases that are just ravaging the systems. There's natural variation in disease resistance. So looking at some of those stocks for these kinds of restorations is something Moat and others are actively involved with. Others can add.
In terms of the fisheries, I think what we're going to be seeing is a lot of the fisheries changing their locations. A lot of the fisheries seem to be moving north. Black sea bass and many other species are just moving more poleward. In terms of things like the North Pacific salmon, it's going to be really interesting to see what happens in coming years. The North Pacific has gotten warmer, and the productivity seems to be going down pretty rapidly. And so the main feeding ground for the North Pacific salmon seems to be diminishing pretty rapidly. And what the impact that's going to be on the stocks, particularly that live further south in California, Oregon, and Washington, is going to be pretty dramatic. I think the bigger concerns further north might be the interspecies competition from different countries having different focuses of what they want to produce. So the Russian production of pink salmon, for example, is going to potentially seriously harm production of salmon, the sockeye salmon in Alaska. But as far as the fish goes, I think you can see a northern shift for a lot of different populations, and it's got some pretty big ramifications.
I'll just add that we've sent some corals to universities for heat resistance, testing that in the reefs. At our clam farm, we've added additional real estate essentially for coral plantation after an airport expansion was built. So providing resources for more corals to settle, in addition to some of the research that's going on with heat resistance for sure.
That sounds very helpful.
I don't mean to put you on the spot because the coral person is not represented here, but I wonder if you know if there's any truth to this statement I'm going to make. I understand, and I recently read that almost 1,200 sites were targeted to transplant corals up and down the Keys, and that after last summer's excessive heat, that less than 20% of those survived. Does anyone have any? Can you collaborate that, or does anyone have any idea about that?
That sounds like what I saw as well. That sounds like that's on the money. We had 100-degree water temperatures around the peninsula last year. Tropical organisms live very close to their upper lethal limits, and that heat is just exacerbating everything else that's going on with the hard coral wasting disease going on now and everything else. That extreme heat is just kind of the push over the cliff.
Sure. I also wanted to mention, I was actually in the Keys during the Insane Heat event last summer, and I was on a dive boat with some of the representatives from Coral Restoration Foundation, and a lot of the videos that Chandler showed in her presentation were of Alligator Lighthouse Reef, and that's where we were, and it was shocking how stressed the corals that were still alive were, and they were doing outplanting and rescue efforts during the time that I was there, but it was very disheartening to see what the water temperature was doing. It was almost uncomfortable to be in the ocean when it was 100 degrees.
So we have the technology clearly to grow seagrass. We have the technology to replicate corals in the laboratory environment. And I guess it really isn't going to help until we can solve the problem of the planet, isn't it?
That's the heavy lift.
Are there corals being developed? I think I heard through Smithsonian that there are corals that they're working on that are more resistant to the heat, unlike the staghorn and the elkhorn.
Well, I wouldn't say I can speak specifically to that, but I mean, I also have read National Geographic articles that seem to indicate that, yeah, on a very limited basis, they may have one or two species that they're able to kind of grow adapted to warmer waters, but they live in such a narrow range and have for millions of years that a lot of these, even several degree changes, are pretty detrimental.
I understand that there's some more evidence of corals moving further north again, and that corals are beginning to show up in higher abundance in 10, 15-meter depths off Fort Lauderdale and even further north. So we may be seeing a poleward shift of some of the corals away from the Keys, and the Keys may just no longer be a functional coral habitat 20, 30 years down the road, which is a frightening thought.
Is mycelium an option to break down like heavy metals and waste and stuff like that at the bottom of these seabeds?
Mycelium.
Fungi?
I can't speak to that. I don't know.
I was just curious.
Other questions? Anybody? Am I missing somebody?
Can we ask questions?
I mean, why not? You're a scientist. That's what you do.
Actually, one of the questions I have is as far as seagrass, and agreed we need to do the heavy lifting of cleaning up the water, but it seems like a lot of the difficulties in propagation is that it all relies on fragmentation because we cannot get these guys to set seed, which is a real rare event. Is anybody looking at tissue culture as a way to produce large quantities of seagrass?
Speaking of somebody's work with fish and ocean for many years, that's really tough situation. Putting them in that kind of environment doesn't necessarily mean that you're going to speed up the process. First of all, you have to get them in tissue culture, in the tissue culture medium, and then they can survive up to a certain point. There is a it's just very difficult in all these processes.
And I don't know if there's a necessity, at least locally. Dennis always had a hard time getting source material through any kind of permit process. I think he was allowed like 6 live shoots on a permit, and you can't do much with that. But there's no restrictions against collecting the uprooted floating fragments. And there's no shortage of those. So we've learned that. And for that last 15 years, that's where all of our source material has come from. You go out after a storm event, and there's lots of material. And if there's enough root stock there, you've got all the source material you can want.
All right. Well, it is 11:55, so let's all thank our speakers once again.
Thank you all for coming out.
Thank you.
Greatly appreciate it.
So I do have some closing comments and speakers. I would like to get a picture of you all before you leave the podium. So thank you all so much for coming to our aquaculture workshops this spring. We really appreciate having you. If this is your first workshop and you missed the last 3, you can view them recorded online for free. Please do that. We've had a really great series. If you want to learn more, like I mentioned before, a lot of our aquaculture work is showcased at the Ocean Discovery Visitor Center and then also during our tram tours. So please grab some more information about that or come find me. We can talk about that as again. The gallery is going to get a little hectic in the next few minutes because we do have some boat tour guests coming back in, making their way to the bathroom and to their cars. So please just be mindful of that. And with that being said, thank you all so much. Thank you, and we will see you at our next event.